Hello, Spark fans, and welcome back to Advancing Spark, where this week we're going a bit academic. So, we're approaching the VLDB conference, and that's a big thing in the world of data academia. So, it's a conference that, unlike all your things like, if you're used to the Microsoft world, you can see Microsoft Ignite and Build, and you see all these different summits, it's quite different. So, unless talking about kind of glossy application use cases in business, we're now talking about the actual underlying tech. Approaches to data management, the paradigm shifts in terms of how we're actually approaching large-scale data management. And Databricks and Spark have kind of quite frequently written papers and put it into VLDB as major innovations happen inside the Spark engine. And this year is no different, and now we've got the Delta Lake paper. So it came out this week, and one of the guys sent it over to me and said I should take a look, and it is super interesting. And I first looked at it and went, well, that's just Delta. That's just explaining how Delta works. And it took a little bit of stepping back and going, oh, wait, this is all of the things Delta's changed about how we work that it's so now mainstream and embedded into our ways of working in data lakes, it's kind of just almost taken for granted. And it really hit home for me when I'm running a workshop yesterday when someone said, so Delta, we heard about it, but that's just about performance, right? It's only if you've got like a massive data set and you really care about performance. And I was like, no, not in the slightest. It's about maturity. It's about treating a data lake as if it was a mature relational database management system. Being able to have all things like ACID transactions, being able to roll back problems if you have problems with your data, being able to actually have really easy data management mechanisms built into your data. And that's what Delta does. And it's really hard because so much of the marketing around kind of Delta Lake and a lot of the big use cases and the stories, they all come down to we've had 10x performance, 100x performance. And it always mentions that nice key, it's gone this much faster. And that is not the killer selling point of Delta for me. It's the, you know what, you can run it like a mature database management system. And that doesn't sound cool, but it really, really, really is the big selling point of how we do this stuff. So if you like the video, don't forget to like and subscribe. And we're going to take a quick look at this paper, and I'm just going to pull out a few of the key highlighted points that really kind of make me go, yeah, that's cool. All right, so firstly, if you go over to delta.io, that's the home of the open source Delta Lake. You can also go over to the Databricks website, and they've got it there. And you scroll down, you see all the things. And again, what I like about the OSS one is the key features. Again, you don't have that big performance strapline at the top. The key features, ACID transactions, scalable metadata, time traveling. It's an open format, so you can use it in lots of different places. They are the key features. That kind of audit history, updates and deletes, massive things that make it more approachable and more usable, and kind of less of a expert, you have to be a big data specialist, more of a, all those things that you do when managing data, you can do it here as well, and also get the benefits of data lakes. Okay, so there we go. So you've got the VLDB paper. So data lake high performance ACID table storage over cloud object stores. It's a mouthful, but actually really, really good paper if you read through it and kind of go through some of the different stories that they're telling. And it's really interesting to kind of hear the story of, I guess from the Databricks perspective, why they implemented Delta Lakes. Like, what were the challenges that they were trying to tackle when they came up with this file format and they put it out there? So you can see the list of contributors, all of the big names in terms of Databricks. So you've got Michael Ambrose kind of leading it. Matej Zaharia is in there, Ren Zinn, got Ali Godzi, the CEO. It is a lot of people across Databricks, UC Berkeley, Stanford, come together in terms of putting this paper together. So it kicks off talking about generally what the problems they're trying to fix, a little bit of an intro blurb. For me, there's two key things I want to pull out in terms of what are they trying to do. Well, achieving performant and mutable table storage is challenging, making it difficult to implement data warehousing capabilities. That is a biggie for me. Data warehousing is the big feature. So for so long, a lot of people have kind of seen things like Spark. Basically, they've seen the big data ecosystem as I have petabytes of data and I'm trying to get one figure and I'm building just a big data pipeline to do a fairly fixed task on a nigh on impossible amount of data. And that's what people think of when you say, I'm dealing with a big data technology or a VLDB. It's I have a real specialist use case. I think that's the key. Specialist is how people see a lot of this tech. And saying, no, you can use it for data warehousing. If you are going to build a data warehouse, and if you've got 500 gig of data, a couple of terabytes of data, to a couple of petabytes of data. Actually, this technology works across all of them and will scale neatly. And that is the big thing. And I keep talking to people who say, don't need Spark, I don't have big data, I don't have a petabyte of data. And that is not the thing. It's like, if you want agility and flexibility, you want real kind of just flick a switch, turn it on, process a load of data, turn it off again, then you can do that with Spark engines far easily than you can with lots of the more mainstream kind of MPP relational engines that you have to turn on a massive cluster. It doesn't scale very easily. And that's a big, big selling point. And it's really good to see, like, that's one of the key features that they're pushing is it's not just for real, big data problems. It's for data warehousing and traditional BI and all that kind of stuff you can now do with it. Okay, and even the example that they pull out is like one of the traditional performance challenges of removing all the records about one user across the table's Parquet files. Like the classic GDPR example. And I've had to do that across straight Parquet. Someone said, can you implement a right to be forgotten? Meaning, can I press a button and I scan through all of my tables, find a certain user, and either kind of obfuscate their data or remove it entirely? And that is a real painful job to do with traditional Parquet. You've got to pick it all up, filter out that row, put it all down again, and you need to build that mechanism. And that's one of the things that they're doing. And there's various other challenges that they're facing. Again, I recommend having a read through. So they designed it so Delta Lake has the metadata in the underlying data store. And that's an interesting kind of comparison of how things are fitting together. Because we obviously have our own meta store. If someone says, where does this lie in the lake? You need something that says, well, the data you're looking for, customers, products, whatever it happens to be, that's going to be in this location. So we always have in terms of data organizational meta store. Could be a catalog, could be something you manage yourself, could do it through Hive. And then you've got the physical metadata. I'm trying to read this table. How do I read this table? And locating that next to the data just means it's available. Doesn't matter if your server's turned off, you can go and see it. And that kind of having that audit store available, even if there's no cluster turned on, it just makes it a much more mature makes it much more easy to support. So that's what's wrong with that Delta table. I don't have to turn on a cluster to query the Delta table. I can go and have a look at that transaction log, and that makes a big, big difference. Again, then talking about all the different features that make it a big, big thing. And again, we've got this nice little definition here. So we're labeling a lakehouse paradigm. That's the key features of warehouses and data lakes together. So standard DBMS management functions usable directly against the low-cost object stores. The whole point of a lake is because it's cheap and because it's flexible. I can sling a new data set in there without having to deploy any code, which is massive. And I can just keep lots and lots of data in there, and I don't have to worry too much about, I'm getting near capacity of my disks, or I need to kind of start archiving that out so it can fit more data in. That's just not something I've thought about for a while. Sure, you might archive stuff for costs, but that's less of an immediate thing. That's just a general maintenance thing you can implement afterwards. But then the whole management area of being able to neatly update things, be able to write a merge statement is huge in terms of the amount of code that saves you. And not having to learn basically the whole awkward way of lifting data up, moving some data out, putting it back down again, merging the two, landing as your table. That not having to implement crazy patterns like that just means you can take your existing patterns that might be in a SQL Server, might be somewhere else, and then go, we'll just run that as Spark. And it will run effectively under the same. And yes, it's doing other things under the hood, but that doesn't really matter. As long as it's very, very simple for people to pick up and work with, then that's great. Okay, so going through some more stuff about that, arguing why people take it up. And Databricks has very large customers, and it's not just for large customers. So it's like, process exabytes of data per day, that's less about how much data their large customers are processing. That's more about just what percentage of the overall Databricks customers are now using this. And again, that's a great thing to hear in terms of the maturity of Delta Lake. Because it has been kind of came out as like, here's a nice little new feature, and it's kind of like you can use it for specialist things, and you put it in and go, should we be using Delta? I quite like Delta, let's put it in. That was kind of like a year or two ago. Now it's you're building a lake, you use Delta. It's the de facto file format, it's the de facto standard, especially if you're in Databricks. It just makes sense to have any kind of managed tables should be in Delta format in your lake. And there's like that real kind of we've hit that milestone of maturity. And actually, we're on Databricks, Delta Lake, 0.7. So I'm kind of getting the hint that, they're heading towards V1. We're going to see a 1.0 Delta Lake at some point, and that's like a key milestone of maturity, similar to how we saw koalas recently. So I don't know if this is a precursor to that, or if that's still a little ways off, but it's still just a sign it's just becoming mature, it's becoming a de facto standard. Okay, so a few things, a bit about like how AWS Gen 2 is very, very good. It's one of the better object stores because you get the folder structures and atomic renaming. A little bit about table storage. So in terms of going in, this is talking about some of the problems of object storage. So some of the problems of data lakes specifically, and why they're kind of putting Delta into it. So talking about things like consistency, talking about the fact that someone could start writing to a file, I try and read that table, I get back half of a written file, and that's obviously terrible. And then that's the kind of thing that alienates a lot of people coming from the standard traditional relational database world. So if you get people that are used to working with a very mature system, and then they try using lakes, and things like consistency problems are things that were solved years ago in traditional database solutions. And so it just immediately switches people off. It makes them skeptical. It makes them go, oh God, it's like working in the 90s, 2000s. It's old school. And so the fact that, we've still got these problems in a lot of traditional data lakes, that's just going to alienate a lot of people immediately. Looking at table storage. So having to work out that kind of Goldilocks situation of two small files is awful because there's a little bit of overhead for every single file. Too big file is awful because it's just massively expensive to change and it's kind of unwieldy. So there's like this Goldilocks thing in the middle of what's the right object size for flat files inside your table. And there's all these things that you used to have to think about in a lot of detail. You have to think about your partitioning strategy. When putting data down, you still need to think about your partitioning strategy. You need to think about your file sizing. Do I need to repartition my table with a load of parameters to get it to the right shape and size before I write my table down so that I can manage the files that are created and make sure that they're the right size? And that's a problem that obviously makes it harder to adopt a lake because people have to think about this specialist stuff they never had to think about before. So going through, they talk about challenges about other options, other ways of doing. So the one big directory problem, so just saying, I could put thousands of files in a single directory, and the problems you get about that, and problems you have about different objects, probably you have about snapshot isolation, a lot of things in there. They talk a bit about custom storage engines. This is looking at things like, so Snowflake are doing very good things in this area. And they're looking at that and going, you know what, that's great, but we can't really see what's going on. We have to access it through a certain kind of connector, a certain pipe. You could have scalability because that's all of your metadata going through a single service rather than just you're reading entirely separate isolated files next to the data. And I don't know. I'm not a Snowflake guy in terms of any of those issues, but they're putting forward that generic argument going, you know what? We can see there could be potential issues in this approach. They're not saying there's a problem with Snowflake. They're not saying there's a problem with any particular technology. They're just saying that approach, which is adopted by people like Snowflake, could have these potential limitations, and that's why they've avoided going that route. And it is interesting because yes, the individual Delta Lake file format on its own, as long as you have something that can read it, doesn't suffer from that. But for a lot of people currently, it can't read Delta. So certainly on the Microsoft side of things, when you've got things like Power BI, you've got other tools like Tableau, you kind of have to go through a Databricks cluster to be able to read those Delta files, just because Power BI can't natively read Delta. So there will be one or two things like that where the file formats can't be read by a tool. But what they're doing in this paper is just saying, you know what, it's an open standard. And they talk a lot about these are the steps we go through when we read from this table. These are the steps we go through when we write to that table to try and say it's not a proprietary locked away format. Any of these BI tools, Power BI or Tableau or anyone else, could build a connector to be able to read this. And these are the steps that you go through to build it. So it's a slightly different approach. So whilst occasionally it feels like it is the same and that you have to go through Databricks, that's not a proprietary lockdown choice. It's until you implement your own reader, Databricks is an option to read these things. Okay, so stepping through, talks a little bit about logs, we'll talk about in a second. Talks about, again, these storage protocols, so how it actually works under the hood. So talks about the file, talks about how they're held again, just Parquet, lots and lots of Parquet. Talks about the log. So the Delta log in particular, when it first came out, it's just that's the Delta log, that's how it works. And you had to go and try and figure that out. So it's got some interesting data talking about why each of those different sections of the log came in. So the actual change metadata, the add remove files, the audit, and of those different sections, you'll see if you open up one of the JSON files inside the Delta log, you can go and get some info about actually this is why we put it in there. Log checkpoints, definitely interesting. And that's one of the first questions I had when teaching a group Delta recently. They're like, look, if we're making a JSON file for every single transaction, every time we change it, and then we're putting this behind streaming, there's going to be thousands, hundreds of thousands of JSON files eventually just constantly chipping away every 5 seconds, 10 seconds as we do a write into that table. That's going to get big. And they've put in this log checkpointing. So actually, it'll just say every X number of JSON files go, oh, and let's compact that into a Parquet file that describes that. Kind of like doing a full backup and then transactional backup. So it's kind of like, this is our last major checkpoint in Parquet. This is everything that's happened since then. And that's now part of it. And you'll just see that if you go into the translog for a busy Delta table, you'll see just Parquet files in there, which are your essentially checkpoint files. Okay, so it talks a bit about that, talk about how we access it, talk about, again, this kind of step-by-step process of this is what you go through in order to access tables. So definitely an interesting read to figure out how it actually works. What is it actually doing under the hood? Again, leave that for you guys to read through yourself. A little bit about transaction range was interesting. So in terms of how quickly you can write data into it. And so they point out a limitation here in that there's probably a limitation that you can write to a table several times a second. Getting into more than that, getting into some millisecond style table updates, they probably see it as a bit of a bottleneck because it has to be serialized. The first update has to be 001, 002, to get that ordering, to get that sequential ordering in the transaction log there's some kind of limit as to when things can write. And now that I don't see that as being a limit for most people. Unless you have lots of different sensors all trying to write data to the same Delta table in parallel and all fighting over kind of who can write first, it's quite unlikely. Certainly it doesn't come up in any of the warehousing conversations I've had. Generally combine it into a single stream and then you're micro batching that stream and writing every 5 seconds or so. That's not an issue. But yeah, they're looking into how they can improve that and how they can raise that limitation. So let's talk about some of the other features. So a bit about time travel, a bit about merge. And again, the ability to take updates and merges is huge in terms of taking existing ETL, existing data warehousing code, and applying it in here. Start a bit about write compaction, all about the data layout. So that whole idea of saying it used to be quite hard. We used to have to think heavily about how we're sizing the different files in our table. The fact that we've got optimize and Z ordering, so we can lay it down more efficiently, we can order it to optimize for file skipping is huge. But also things like auto-optimize. Things like going, you know what, just get a best guess when I put the data down. And that whole question we had earlier of what's that Goldilocks file size? So optimize gives us the 1 gig. You want to go about 1 gig is a good file size for a Parquet. Much, much, much smaller, and it starts to get inefficient, much bigger, and every time you change it, you've got a big load of redundant data movement. About a gig is right. And then auto-optimize is the best guess. I'm not going to slow down ETL too much. I'm not going to slow down your writes into the table, but we'll organize it to about 128 meg, just to get you to a decent state. So it gives you that little threshold going, this is like your minimum bar to entry, get it at least 128 meg, please. And then above that going, and then if we're taking time to actually do it properly and sort it out, maybe in a maintenance job out of hours or another time, then 1 gig's what we want. So you've got like these couple of different ways just to make it so you don't have to think about it, which is all about database maturity, right? It's trying to say, to do a simple thing like write to a table, you don't have to consider as much as you used to all these different considerations. It's think about partitioning, write your data down, tidy it up later, compact it later, optimize it later. And all of these things are real good features that just help reinforce that it's a mature data management platform. It's not a Wild West lake that you can go and query. And, sometimes the data might even be right. That is by far the days of old when we're talking about lakes these days. Get a load of stuff, don't have time to go into. So schema evolution is huge, connected to different things. And then a little bit about use cases. And again, so happy that use cases start off with number 1, data engineering and ETL, moving data around, how all these features have been geared to make that process easier, more adoptable, more straightforward, more mature. So things like asset transactions, things like update and merge, time travel. So if you do a massive update and makes a lot of changes, you can go, wait, let's just see what it was like before that change, after the change. Okay, so we can sense check things. Or we can run reporting that says, actually, at the end of this, tell me exactly what changed by doing a temporal query before and after. You can do loads of stuff around that. You can do rollbacks in case of emergencies. We've got an audit log of who went and deleted all those rows. We know who did it. We can now put comments against the Delta log transaction saying, I'm doing this as part of this automated job at this time for this slice of data. We can actually now track our changes, like go and kind of comment in there. Talking about data warehousing and BI. So away from just straightforward ETL and kind of I'm just prepping data to, you know what, I'm actually building a star schema, I'm building a reporting model, I'm doing data analytics. And having that as a use case rather than I'm trying to understand one thing, I'm trying to prep a feature store to do some data science. This kind of bringing on you know what, there's a hell of a lot of business users that just need dashboards and they need drag and drop analytics, they need self-serve. And traditionally that's always been so you get your lake, you get your good data set in the lake, and then you pick it up and you put it somewhere else to do BI on it. And it's more trying to say, well, here's all the different things that Delta does to actually make that more appropriate to do in the lake. So especially Spark 3, all things like dynamic partition pruning, things like the AQE, all the kind of the performance things. And yes, we are talking about performance now, but performance over small data. So when we're talking about tens of million rows, then actually making that a performant query. Because actually, when you're talking dashboarding and people are expecting like millisecond style response times, and when your response times are a couple of seconds, it's like it just feels a bit it's clunky. So all the things that they're doing to actually just make that, just hack that down and down and down and down. And there's always going to be a little bit of overhead of parallelism, but just trying to tackle that with caching, with the new vectorization engine that they're bringing in, all that, which is the Delta engine and Photon and all that kind of stuff, is all kind of leading towards that. It's all like challenging that conception that Spark's always going to be a little bit slower than this kind of in-memory semantic model. It probably is, but it's also challenging when it gets to the point going, yeah, but is it that much slower? Is it so much slower that it's just not easy to just keep it all in one place and then manage it with caching and like some more being able to use cached SSDs and all that kind of stuff to try and challenge that? Okay, so we're then looking at some specialized use cases. There's a few things in here, again, super interesting stuff to dig into. One for me is there's a particular use case where there's several hundred developers all working on a single data pipeline. And that kind of in old school data lakes would have been absolute abject chaos. Just half-written files, clashing writes, various file locks, just all sorts of problems that can go in there. And so because they were using Delta, using things like auto-optimize to tidy up the files, time travel asset transactions, just in terms of making sure you keep transactional consistency, is a huge thing in them saying, and now lots of people can use this at once. It's not if you need something, go talk to the one specialist data engineer who knows what he's doing. It's anyone can work with this stuff. And again, really, really good use cases and really going to be pushing it out. So there's a lot of performance stuff in here. And again, I didn't really want to go digging too much into performance. The one thing I did highlight is it's looking not just at here's the big giant petabyte, exabyte, we can process huge, insane amounts of data, but also, you know what? Look at the performance over a small table. I say small, I think it's 33 million. So it's not tiny. We're not talking about, a couple of thousand row dimension tables, but like a fact for a SME. Like, so, if you're kind of a small, medium business and your entire warehouse might be 33 million rows, 50 million rows, something like that. And actually just saying, you know what, we've tweaked and tailored performance for that kind of story. In this case, it's because there's tons and tons of partitions, which is normally a terrible, terrible performance use case. And saying, look, a lot of the challenges, a lot of the data patterns that people have just from the nature of their data, we're putting in different performance things and tackling all these different scenarios. Not just I've got a mass of data and can't deal with it. Again, it's looking at big data is not just about volume. It's about all the other problems that you have with data of veracity, truthfulness, which all the transactional consistency and all that kind of stuff is a big, big part of. The auditing is a massive part of. Looking at velocity. So streaming, being able to stream into it, and the auto compaction to tidy up files as you go. So you're not left with millions of tiny files which don't perform. All of these things are just tackling all of the other parts of dealing with a modern data solution. Okay, so I don't want to go too much into performance. Again, it is really interesting stuff. Discussions. So the limitations that they found. So again, the fact that you don't need another system to manage your metadata for those individual files when you go and look at it is awesome. And that again means it's extensible. It means anyone can kind of basically build their own data Delta reader. If you can read Parquet and you can read JSON, then you can read a Delta table just by doing which file should I get? What's my latest checkpoint? Go and read those files, which is again a really nice, slick, open system. A little bit about interesting point about secondary indexes. So Delta does not currently support secondary indexes. So if you built your partition structure, you put Z ordering, which is kind of like your clustered index, so it's ordering how the data is stored across files to encourage data skipping. And this is saying they've started prototyping a Bloom-based filter index. So the ability to have additional search indexes that you can put across your files going, actually, here's the bits of data that you want. Here's how best to read it. Now, that's not going to reorganize your data. It's just going to help it better find the data that's inside your files. It's one of the problems that you've got with the min-max. So min-max, I might say I've got all records from starting with A, starting with F. And then it might not actually have the value I need because that's in several other files. So Bloom index saying it is absolutely in files 1, 5, 9, and 7. Go and read those files. So digging into Bloom filter indexes, not something I use a lot. Actually, used to be over on the SQL Server kind of things, and that's B trees all the way. The one criticism the Bloom filters get is it might have a false positive. So you might read an extra file than you need in rare circumstances. And then again, that's great, because again, worst case, I do a little bit of extra work. But it's not you're going to miss files. So as long as you get all the data, and if you get 1 or 2 extra files, you're still going to be reading less data than you were immediately. So actually this kind of stuff saying, can I just add some additional indexes in different configurations? Because I know people are going to be searching for this, which takes away some of the pressure of Z ordering. So I can Z order on the ones that I know people are always going to search on, then add some additional filters in. It's a little bit like what Microsoft have done with the hyperspace. So it's looking at kind of creating an additional index structure on top. Except Microsoft's one has like a covering index. It has some of the data in there. Whereas I'm assuming this one will just be pointers to which of those Parquet files inside that Delta table it should be going reading to. But didn't know they were working on that. That is awesome that there's kind of additional performance, additional indexing, additional things coming. There's a little bit of discussion about alternatives. So Apache Hudi, Apache Iceberg have similar approaches. Things they don't have is the Databricks Delta special stuff. So things like the, like optimize, the file compaction, the Z ordering, they are the performance tweaks. They are the things that make the Delta tables really, really fly. But again, it's a different thing. And for me, it's adoption. So certainly if you're in the Microsoft ecosystem like I am, then one, Databricks is prevalent. So actually being able to use Delta is just baked in straight away. But even with Azure Synapse, the upcoming Spark engine from Microsoft, that's got Delta Lake baked in. Look at the SQL on demand, looking at being able to just query Delta Lake. So Delta Lake Delta files are becoming this kind of first party across the Microsoft data platform, which is fantastic. So it's I would only be considering the other options of Hudi and Iceberg if I was not working in the Microsoft platform. If I wasn't using Azure, I was using something else and building my own Spark environment, then they're definitely options to investigate. But for me, it's so mainstream and built in now that it just makes sense to use Delta. Okay, and finally, to finish things off, it's all about simplification of architectures. That's the point they make at the end. So it's used across thousands of organizations, processing exabytes of data a day, sure. But it's oftentimes replacing more complex architectures. So it's all about saying we used to have several components inside our architecture to achieve our aims. And now actually we're getting to the point where we can say, you know what, my data lives in one place, it's in one file format, and all my different use cases can adopt that same pattern. So I definitely recommend having a look, having a skim through that paper and just seeing, I guess, going on that journey of the problems they saw, why they implemented it, the key features, and how they see those features as fixes to some of those things. Because there's been a little bit of a pattern of you see features come out to Delta and you're like, what's that for? And I was very similar when Clone first came out. So I saw clone announced, and I was like, all right, I make copies of my data, sure. And then digging into the shallow clone, and in the video I did for that, kind of you see all the different use cases going, oh, I can use it for trials and experimentations and budget forecasting and running simulations and trying things out in prod before I actually do it. Just tons and tons of use cases suddenly spill out, and it's like, oh, there's tons there. And this is great to kind of see some of the reasoning, some of the arguments, some of the kind of the whys and wherefores as to where Delta came from and why they got it in. So definitely recommend having a run through the paper, basically just familiar myself with their train of thought and some little hints in there about where they're going with this tech and kind of what they see it being in the future. So awesome stuff. Definitely interesting. If you're not using Delta already, you should be. If you're using a Delta Lake, if you're using a data lake, and you're using things like Spark, using Databricks, then 100% these days, it's a no-brainer. Delta Lake is just the file format that we use when we're inside a lake. Because it has become that prevalent because of all those features, because of the safety, because of the maturity, because of the management functionality, the ability for several different people not to kill each other's work and create corrupted records. So yeah, really good timing with this, obviously with the VLDB coming up. Just arrived at the same time as my Spark Summit swag, so I've got my Data Teams Unite t-shirt on. And yeah, if you like the video, don't forget to like and subscribe. Let me know your comments and thoughts. Is there any reason you're not using Delta? And I'd love to know why. What are the reasons someone would, at the moment, in terms of how everything's working, wouldn't choose to adopt this given all the features and the things it gives you? All right, leave it at that, and thanks for watching, and see you again.